Continuing, we are at number 18, which deals with a car dealership that sells cars that are identified as being either red or convertibles, not red, not convertibles. They don't care about any other aspects of the cars. They don't care about 2 doors, 4 doors, nothing else. This information is just concerned with whether it's red or not, convertibles or not. Might notice if you've looked, that symbol right there does not universally in math. It doesn't necessarily universally mean not, but in a lot of courses, that's a not symbol. Sometimes they do it as a squiggle. I chose that one. This question in the book does not use any symbol of any kind. I just wrote it rather than writing the word not. So that means not. So not a convertible, not red right there. So anyway, I changed the numbers from what they gave us, and I'm going to put the information down in either what's called a contingency table or a Venn diagram. And you'll see I didn't quite finish either of these because when I do it this way, I actually have a slight issue. I can continue on this one a little bit. If I know that I have a total in this row, in math, rows go this way, columns that way, so a total in this row 30, and I already have 5, that would leave 25 more to go there. Knowing that this column has a total of 70 means I could subtract 70 minus 25 and get a 45, but I wouldn't know where to go from here. I would need at least one more bit of information. Like if I had something about the total number of convertibles, if it was, for example, 30, then I could continue onward, and I could say, well, if I have a total of 5 red convertibles and the number of convertibles is 30, it must leave 25 to be non-red. And then I could finish filling this out in that way. 25, 45, that's 70. That would make a total of 100. So if it were just the number of vehicles, I need one more bit of information. And it'd be the same thing over here. It'd be kind of tough for me to have filled it in with just the 5, the 30, and the 70, because I wouldn't know how many go there or around the outside without one more bit of information. So I would always need a little bit more. When I put down number of convertibles was a total of 30, now I could say this would be a 25 here, and I could continue onward. So you need the correct bits of information to write this stuff down. Either of these will work. I'm going to stick with this one. I think it's in general a little bit more usable, maybe not quite as visual, but either of them work. We're going to use this one. If this was 100 convertibles total, then I'd have, for example, that 5 would have been 5 out of 100, which would have made it 5%. Your course actually makes these percentages. I left it off. You can put the number of elements in there, right? Had it been the number of elements, I would have needed to have added one more thing to what they gave us. Because when I only had the black stuff that I wrote, we just didn't have enough information to continue without one more bit of information. When I just had this, all I could really do was fill in this position here with a 25 and that with a 45, and then I was stuck. So if it's just the stuff that I wrote down on this board, I couldn't finish. But when they made it percents, percent always means parts out of 100. So when they told us these were percentages, kind of means I can just say, well, we must have 100% for the total. That lets us continue because that tells us now if that's 30, this must be 70, and we can kind of go from there. So these contingency tables can be used for the number of elements or for the percent or proportion of elements. It works either way. If they give you how many things there are, you can write the numbers down. If they tell you what the percentage is, you just say the number is 100. So this could be 100 cars or it could be the percent. So whichever they give you, put them down this way, figure out your extra positions. If we have a total of 100 and 70 is here, that must be 30, which means this must be a 25. 30 and 70, we just go from there. I did not write down the question they actually asked. Given that a car sold by a salesperson is a convertible, when they say given, it means that we know that it happened. There is no doubt whatsoever. So given it's a convertible, when you have your stuff organized in a contingency table or in a Venn diagram or any other way, if you have it organized like this, when they do a given part, go straight there. This given that it's a convertible, I'm going to use blue, means we know that took place. That means we are in this column. Nothing else matters for us because we know that took place. So easiest way is not to do the math formulas. I will show you the formulaic approach too, but the easiest way is to say, I know I'm in this column, so we have 30 total, 5 of which are red, 25 are not red. We know we're there because we were given that it's a convertible. The way we'd write this, we'd say probability of something. They always do a vertical line and then write convertible after it, and abbreviate. So this probability, when you see something here, I think they said red, what is the probability that it is red? A lot of times people misread these. That's the given, and you are given convertible. Right? We don't know it's red. They're asking us what the probability is that it's red, given that it's a convertible. And just like on the previous 2 or 3 of them previously, we're going to do a fraction because probabilities are always fractions. On the bottom is the number of events in the sample space or the total number of ways of doing what we are doing. We are randomly choosing a car, but it is from this column. So if I looked at this as the number of vehicles, I'd say there are 30 cars, therefore there's 30 ways of choosing it. So randomly choosing a car, 30, because we're in that column. What is the probability that it is red? In this column, 5 of them are red. We would have this. Rounded to 3 decimal places, it's 166 forever. So that there, if it were the probability of red given convertible. In terms of math formulas, because you might get that, I'll use green for the formula. They give you a formula that says the probability of A given B, bottom of the fraction is always the given. It's the thing that you know you did, so it's still a number of ways of doing what you're doing. Top, I'm looking to get A, what I'm concerned with is the A, but if I know B took place, I have to include B as well and say it's A and B. For us, we would say fraction given convertible. On top would be red and convertible. It's already harder than just doing that, but if you want formulas, we have them. Bottom of the fraction, probability of a convertible. I'd be ignoring this blue thing and saying I'm choosing from 100, 30 of which are convertibles. On top, red and convertible would be the 5 out of 100. So I'd set it up as what's called a complex fraction. And no reason in the world why I would do it except to show you the formula. Dividing by a fraction, same as multiplying by the reciprocal. So instead of 30 on top and 100 on the bottom, it's 100 on the top and 30 on the bottom. My 100s cancel, and there's my 5 out of 30, or 1 out of 6. So with formulas, it still works. But again, if you have a given like we do in this one, where they told us that it was a convertible, you can just go straight here, and if we know it's a convertible, I could just get rid of that whole entire thing and say none of that matters. This is all we need once they told us it was a convertible. Just that. So anyway, that was number 18.